Good morning, everybody. This is Raiyyan, Malik, and Mangesh Sharma are here presenting our poster on Replica Path Design for High Speed DP SRAM with fast reset. Random access memories, the sense enable, and the reset signals are the most critical because we need to replicate the worst case of the memory array for the reading operation and writing operation. Now let us talk about the working of replica path. A reference word line is generated by the row decoder, which is just similar to the word line of the memory array. This reference word line goes to the half of the width of the memory array and returns back, therefore depicting the worst case memory cell of the array. While returning, it can activate a multiple number of bit cells due to which this reference bit line discharges much faster as compared to the worst case memory cell array. By discharging this reference bit line, a sense enable is generated. This sense amplifier enables signal activates the sense amplifiers and reading operation is carried out. As shown in this diagram, the word line and reference bit line are similar, but due to multiple activation of bit cells, the reference bit line discharges much faster. The rising edge of this SAEN is generated when there is sufficient difference between bitline and bitline bar. As the SEN runs across the whole memory width of the array, we have proposed an architecture in which the SEN can be locally regenerated. In our architecture, the reference bit line generates the SEN signal, and these SEN signals are fed to local SAE regeneration circuits, which generates a local SAE, which act as a sense enable of the sense amplifiers. Now we can see this reference word line activates multiple number of bit cells. Depending on the number of bit cells, either we can have power wastage or read failure. In our architecture, when 7 number of cells are activated, the SAE or local SAE arrives at the most appropriate time, satisfying the sense enable offset. Now Mangesh Sharma will discuss about the reset dummy.
By reducing wordline pulse width, we can aim fast reset. The pulse width of the wordline should be sufficient for bottom wing first row. For this, we have used active low clock to generate early wordline, whereas actual wordline is made from clock row decoder. To make it even more faster, buffer has been removed and the dummy wordline is directly connected to the reset. The conclusion of this work is that to satisfy sense amplifier offset, the number of the activated cell by the reference word line plays an important role. For fast reset, early word line is generated by neglecting the load of the clock, whereas array word line is generated using the loaded version of the clock. Thank you.